Hi guys, welcome to my channel. I'm Lisa Amalia Iksan who will help you to learn physics. Then, what will we discuss today? Are you curious? Check this out. Heat transfer is a discipline of thermal engineering that concerns the generation, use, conversion, and exchange of thermal energy or heat between physical systems. Heat transfer is classified into various mechanisms such as thermal conduction, thermal convection, thermal radiation, and transfer of energy by phase change. Engineers also consider the transfer of mass of differing chemical species, either cold or hot, to achieve the heat transfer. While these mechanisms have distinct characteristics, they often occur simultaneously in the same system. Heat is defined in physics as the transfer of thermal energy across a well-defined boundary around a thermodynamic system. The thermodynamic free energy is the amount of work that a thermodynamic system can perform. Enthalpy is a thermodynamic potential defined by the letter H that is the sum of the internal energy of the system U plus the product of pressure P and volume V. Joule is a unit to quantify energy, work, or the amount of heat. Heat transfer is a process function or path function as opposed to function of state. Therefore, the amount of heat transferred in a thermodynamic process that changes the state of a system depends on how that process occurs, not only the net difference between the initial and final states of the process. Thermodynamic and mechanical heat transfer is calculated with the heat transfer coefficient. The proportionality between the heat flux and the thermodynamic driving force for the flow of heat. Heat flux is a quantitative vectorial representation of heat flow through a surface. In engineering context, the term heat is taken as synonymous to thermal energy. This usage has its origin in the historical interpretation of heat as a fluid, caloric, that can be transferred by various causes. And that is also common in the language of layman and everyday life. The transport equation for thermal energy, Fourier's law, mechanical momentum, Newton's law for fluid, and mass transfer, Fick's laws of diffusion are similar. And analogies among these three transport processes have been developed to facilitate prediction of conversion from any one to the others. Thermal engineering concerns the generation, use, conversion, and exchange of heat transfer. As such, heat transfer is involved in almost every sector of the economy. Heat transfer is classified into various mechanisms such as thermal conduction, thermal convection, thermal radiation, and transfer of energy by phase change. The fundamental modes of heat transfer are conduction or diffusion, convection, and radiation. Heat conduction, also called diffusion, is the direct microscopic exchange of kinetic energy of particles through the boundary between two systems. When an object is at a different temperature from another body or its surrounding, heat flows so that the body and the surroundings reach the same temperature, at which point they are in thermal equilibrium. Such spontaneous heat transfer always occurs from a region of high temperature to another region of lower temperature, as described by the second law of thermodynamics. Heat convection occurs when bulk flow of a fluid, gas or liquid carries heat along with the flow of matter in the fluid. The flow of fluid may be forced by external process or sometimes in gravitational fluids. By buoyancy, force caused when thermal energy expands the fluid, for example in a fire plume, thus influencing its own transfer. The latter process is often called natural convection. All convective processes also move heat partly by diffusion as well. Another form of convection is forced convection. In this case, the fluid is forced to flow by use of a pump, fan, or other mechanical means. Thermal radiation occurs through a vacuum or any transparent medium, solid or fluid. It is the transfer of energy by means of photons in electromagnetic waves governed by the same laws. Okay guys, so our learning is over. Yay! It's the end. So, thank you for watching this video. I hope you understand and feel helpful. Continue learning your physics, okay? Fighting!